everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, and that has been the class we have here is your which has been the 20th class of the session. And as you know that we had done your 19th class here in the last classes. So in 19th classes we had done your started with unit 1, which has been the name we have here. So here we go ahead for the sessions here, but before starting with this here in the unit 1 only, that we had discussed about the second method and the bisection method, Newton-Raphson method, as well as we had done your successive iterative method as well, and synthetic division we are dealing with. So here, before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. In terms of 20th class, I will start discussing about the question first, that is being the use synthetic division with x is equals to 1 to find f dash 1 and f double dash 1 for the equation fx equals to x cube minus x square minus 1.0001x plus 0.9999 equals to 0. That's what we have to cover up here. So we go ahead. Use synthetic division with x equals to 1 to find f dash 1 and f double dash 1 for the equation fx equals to x cube minus x square minus 1.0001x plus 0.999 and 9, that is being here, equals to 0. So for that we'll have to find it out here, and we'll go ahead for the same. So here the coefficient of the above polynomial is, that has been a0 is equals to 1, a1 equals to minus 1, a2 is equals to minus 1.0001, and a3 is equals to 0.999 and 9. So let us perform synthetic division beginning from p equals to 1 up to third level. So we go ahead for the same here. So here we got this, that we'll find it out, and that what we'll have to discuss about the table we'll made it. So we go ahead here. For that p equals to 1, a0 equals to 1, a1 equals to minus 1, a2 equals to minus 1.0001. Then we have your a3. For that it is a3 is equals to 0.999 and 9. So we go ahead for the same. It will be exceeded. So okay, we'll go ahead for the values that we'll have to find it out for the same. And that is for p1 equals to, when a0 is that, it will be dash, and that b0 equals to 1, b1 equals to 0, and b2 equals to minus 1.0001. For another we have b0 is equals to a0, which is equals to 1, b1 equals to 0, p2 is equals to minus 1.0001. The next we'll have is dash bc0 equals to 1, C1 equals to 1. Then C0 is equals to B0, which is equals to 1. C1 equals to 1. For that, it will be B0 is equals to 1. And then again we have here, which is we'll have to talk about it, which is being your D0 is equals to C0, which is equals to 1. That we have. For that above table, we go ahead here, and that what we will have to talk about it. So for above that table, that you have to observe that the successive remainder for C2 onwards are basically equals to 1 upon that n determinants fn fp that we have. For dash, we'll talk about it as your f dash 1 equals to minus 0.0001 into 1 denominants is equals to minus 0.0001 here. And for f double dash is equals to 2 into that is being equals to 4, that we have your value. Now we go ahead for the next question that we have to talk about it, which has been of course the important one here. We'll go ahead with another question here. The question is, find the roots of equation x cubed plus 2x squared plus 10x minus 20 equals to 0, that is near 1, using Birch-White method at the end of the second iteration. We go ahead for the same. Find the root of equation x cubed plus 2x squared plus 10x minus 20 equals to 0. That is near 1, using Birch So here we go ahead. So with the same with Birch-White method at the end of second iteration. So with the same we go ahead further, that the coefficient of the polynomial we have a0 is equals to 1, a1 equals to 2, a2 equals to 10, a3 equals to minus 20, and n equals to 3 here. So we'll go ahead for the solution here as well. We'll make for the iteration 1 that we have to discuss here. So for iteration 1 we go ahead. Iteration 1 is equals to, that is what we have to discuss here. E0 is equals to 1, 1, 2, 3 that we have. So for the same we go ahead here, and that will make a table for a0 equals to 1, a1 equals to 2, a2 equals to 10, and a3 is equals to minus 20. So we'll put the value here, and that what we'll have to discuss, which is being that is being dashed. b0 is equals to 1, b0 b1 equals to 3, and p0 b2 equals to 13. So for the next, it has been b0 equals to a0, which is equals to 1, b1 equals to 3, b2 equals to 13, and b3 is equals to minus 7. For the another we have here is being p0 c0 is equals to 1, p0 c1 equals to 4 here. And for the next we go ahead here, and that what we'll have to discuss, which is being another one. And that is being C0 equals to B0 equals to 1, C1 equals to 4, and C2 is equals to 17. So for that, we'll go ahead. P1 equals to P0 minus B3 upon C2 equals to 1 minus 7 upon 17, that is being equals to 1.41176. Now we'll go ahead for iteration 2. For iteration 2, we made a table here. That is P1 equals to 1.41176. So for the same, it will be, so for the same way it will be that we made it out. And here it is A0 equals to 1, A1 equals to 2, A2 equals to 10, and sorry, A1 A0 equals to 1, A1 equals to 2, A2 equals to 10, and A3 is equals to minus 20. So for that, we'll put the value and we'll find it out for the same. So here we go ahead. B1 B0 equals to 1.41176. B1 equals to 4.81659, and B2 is equals to 20.917414. So for the iteration 2, as we had made it here, and that what we had even though done to it, so we'll go ahead for the same and we'll just made it out for it as well. So on the same cases, we go ahead for the iteration, and that is for 1.41170, and that has been for the second one, it has been B0 is equals to A0, which is equals to 1. This is B1 is equals to 3.41176, B2 is equals to 14.81659, and B3 is equals to 0.914746. For this, P1 is equal, C0 is equals to 1.41176, P1 C1 is equals to 6.80965. Here C0 is equals to B0, which is equals to 1. C1 equals to 4.82352, and C2 is equals to 21.62624. For P2 equals to P1 minus B3 upon C2, which is equals to 1.41176 minus 0.91746 upon 21.62624, which is equals to 1.36933, that we get, and thus the approximate root at the end of the second iteration, which is being your the x2 is equals to P2, which is equals to 1.36933, and fx is your, which is being f 1.36933 is equals to 0.011 here. Now we go ahead for the another question that has been important for you all, and which is being about explain a Bystrom method, which has been the Bystrom method as well. So we go ahead for the same, and the method that we'll discuss here in the detail about it, and you will get to know about it, and then we'll implement that as in the form of the question as well. So here we go ahead for the same. So here explain Bystrom method. which is being Bystrom method. In the same here, in this method, the quadratic factor x squared plus bx plus q is extracted from the polynomial fx of degree n. The remainder polynomial is rx plus s of degree 1. The quotient polynomial fn minus 1 x is the degree of n minus 2. It will be given as fn minus 2 x is equals to b0 x n minus 2 plus b1 x n minus 3 plus bn minus 3 x plus bn minus 2 for the same. And then the polynomial fx will be, which is being in the form of fx is equals to x square plus bx plus q fn minus 2 x plus rx plus s. So this has been here the quadratic factor. This has been the quadratic factor. This has been the quotient, and this has been the remainder. On the same cases, you have to let the initial approximation to p and q, that is b in p0 and q0 respectively. Then the synthetic division is being performed, that to be as given as, and that what we have to implement as well. So that is the synthetic division for the Bystrom method. We'll go ahead for the same. So for that it is b minus p minus q, and this was being minus p minus q, and for the same it will be like this. Let's go ahead for the same. A0, A1, A2, AN minus 2, AN minus 1, and AN. For the same it is minus P, P0, minus P, B1, minus P, Bn minus 3, minus P, Bn minus 2, minus P, Bn minus 1. For this it has been minus Q, B0, pH has been 0, minus Q, Bn minus 4, minus Q, Bn minus 3, minus Q, Bn minus 2. For the same here, B0 is equals to A0, B1 equals to A1 minus P, B0. Here B2 is equals to A2 minus P, B1 minus Q, B0, Bn minus 2, Bn minus 1, and Bn. Here this has been minus PC0, minus PC1, minus PCn minus 1, minus PCn minus 2. This has been minus UC0, minus QCn minus 4, minus QCn minus 3. This has been C0 equals to B0, C1 equals to B1 minus PC0, C2 is equals to B2 minus B C1 minus Q C0 Cn minus 2 and Cn minus 1. This has been the synthetic division for the Bystrom method, where then the values for the delta P and the delta Q that are to be given as here, and which has been as follows, that what we will have to discuss here. So here we go ahead. P equals to minus Bn Cn minus 3 minus Bn minus 1 Cn minus 2 upon C square n minus 2 minus Cn minus 3 Cn minus 1 minus Bn minus 1 for delta Q minus Bn minus 1 Cn minus 1 minus Bn minus 1 minus Bn Cn minus 2 upon C square n minus 2 minus Cn minus 3 Cn minus 1 minus Bn minus 1. So the improved value of P0 and Q0 that are to be given as is being P1 equals to P0 plus delta P, Q1 equals to Q0 plus delta Q. So the deflated polynomial is to be given as in the form fn minus 2 x equals to P0 xn minus 2 plus B1 xn minus 3 plus Bn minus 2. So the next quadratic factor is to be obtained from this deflated polynomial as well. Now we go ahead for the next, we'll talk about it. That has been the another question which we have to discuss here, and that has been the important one, of course. The question is, find the quadratic factor of x to the power 4 minus 1.1 x cube plus 2.3 x square plus 0.5x plus 3.3. That what we have to discuss here, which has been equals to 0, and after the two iteration using the Bystrom method, use P0 is equals to 1 and Q0 is equals to 1 here as well. So with the same we go ahead. That has been form has that has been becoming a long question that we'll be solving here. And if we talk about the other than that, so of course then we'll start discussing about the attic and acceleration of the conversions as well. So with the same we go ahead here in the detail about it. So not a problem, we'll deal with it. So the question we have as follows. Find the quadratic factor x4 minus 1.1 x cube plus 2.3 x square plus 0.5x plus 3.3 equals to 0 after two iteration using Bystrom method. Use P0 equals to 1 and Q0 is equals to 1. So we'll deal with the same. So we go ahead for the same. So that has been A0 equals to 1, A1 equals to minus 1.1, A2 is equals to 2.3 and A3 is equals to 0.5, A4 equals to 3.3 and N is equals to 4, P0 equals to 1 and Q0 equals to 1 as well. So we go ahead for the solution for the iterations, that what we have to talk about it, and we go ahead for the iteration 1 here first, and for the same we'll be solving it out as well. So for iteration 1, so that the synthetic derivation will be made here. So that will be minus P0 is equals to minus 1 and minus Q0 is equals to minus 1. That is being Q0 is equals to 1, A0 is equals to 1. Then we have your A1 equals to minus 1.1, A2 is equals to 2.3, A3 is equals to 0.5, and A4 is equals to 3.3. So for the same, we go ahead here and we'll put the value for the same. For the same here, and that what we'll have to discuss about it, which has been important one. So with the same, that has been for A0, this has been for 0 that has been detached, minus P0 B0 is equals to minus 1, minus P0 B1 equals to 2.1, minus P0 B2 is equals to minus 3.4, and minus P0 B3 is equals to 0.8. The another we have here, which is minus Q0 B0 is equals to minus 1, minus Q0 B1 equals to 2.1, minus Q0 B2 equals to minus 3.4. B0 is equals to A0, which is equals to 1. B1 equals to minus 2.1. B2 is equals to 3.4. B3 is equals to minus 0.8, and B4 is equals to 0.7. Minus P0 C0 is equals to minus 1. Minus P0 C1 equals to 3.1. Minus P0 C2 is equals to minus 5.5. Again we have minus Q0 C0 is equals to minus 1. Minus Q0 C1 equals to 3.1. C0 equals to B0, which is equals to 1. C1 equals to minus 3.1. C2 is equals to 5.5, and C3 is equals to minus 3.2. That is for the iteration 1 here, that we'll have to discuss about here in the detail here, that we have to discuss as well. So we'll go ahead for the another one, that has been P1 equals to P0 plus delta P is equals to P0 minus B4 C1 minus B3 C2 upon C2 square minus C1 C3 minus B3. So that is, we'll solve it out. We'll put the value, of course, 1 minus 0.7 minus 3.1 minus 0.8, 5.5 upon 5.5 square minus 3.1 minus 3.2 minus 0.8, which will give you 1 minus 22.81, which is being equals to 0.902235. For Q1, that is being equals to Q0 plus delta Q. So that is being equals to Q0 minus B3 C3 minus B3 minus b4 c2 upon c2 square minus c1 c3 minus b3. So we'll put the value here. 1 minus 0.8 minus 3.2 minus 0.8 0.7 5.5, which is being upon 5.5 square minus 3.1 minus 3.2 minus 0.8, which is equals to 1 plus 1.93 upon 22.81 equals to 1.084612. So for iteration 2, we go ahead here that we have to talk about it, and that has been, of course, been the important one here. So for iteration 2, it will be the following table that to be illustrate the synthetic division here, and we'll put the value for the same. This is what minus b1 equals to minus 0.902235 and minus q1 equals to minus 1.084612. This is for a0 equals to 1, a1 equals to minus 1.1, a2 equals to 2.3, and a3 is equals to 0.5. Then we have your a4 is equals to 3.3. So we'll go ahead for the same with these values. So on the same cases, so we'll find out the value for the same here, and that has been minus b1 b0 minus 0.902235. This is minus b1 b1 1.806486. This is minus b1 b2, which is being your minus 2.726441. This is minus b1 b3, which is 0.049436. So here it is, that is being representing minus q1 b0 minus 1.084612 minus q1 b1 2.71171648 minus q1 b2 minus 3.277561. That is being your b0 is equals to a0, which is equals to 1, b1 equals to minus 2.002235, b3 is equals to 3.021874, b3 equals to minus 0.54793, and b4 is equals to 0.071875. For the next we have here, which has been for the another one, minus p1 c0, that has been the minus 0.902235, minus p1 c1 is your 2.620514, and minus p1 c1 is your minus 12185. Then again we have minus Q1C0 minus 1.084612 minus Q1C1, that is 3.150223. C0 is equals to 0 equals to 1. C1 equals to 2.90447. C2 is equals to 4.55776. C3 is equals to minus 1.016755 that we have. This has been the table. Now we'll go ahead for the P3, which we have to find it out here itself, and that has been the important one, of course. So P2 is equals to P1 plus delta P equals to P1 minus B4 C1 minus B3 C2 upon C2 square minus C1 C3 minus B3. There has been putting the value here 0.902235 minus 0.071875 multiply minus 2.90447 minus 0.54793 4.557776 whole upon 4.557776 square minus 2.90447 minus 1.016755 minus 0.054793. That is being equals to 0.902235 minus 0.040975 upon 17.979332, which is equals to 0.9. And where we have another one that has been for the Q2. Q2 is equals to Q1 plus delta Q, which is equals to Q1 plus minus B3 C3 minus B3 minus B4 C4 C2 upon C2 square minus C1 C3 minus B3. We put the value here minus 1.084612 minus 0.054793 minus 1.016755 minus 0.054793 minus 0.071875 multiplied by 4.5577776 whole upon 4.5577776 square minus 2.090447 minus 1.016755 minus 0.054793. We'll go ahead 1.084612 minus 0.274881 upon 17.974332 equals to 1.1. So the quadratic factor that we have, the quadratic factor that has been given here, which has been equals to x square plus px plus q is equals to x square plus p2x plus q2, which is equals to x square plus 0.9x plus 1.1. that we have as an answer, and that's what we'll have to go ahead for the same. So here we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, we talk about it. Yes, we had done your sociology and software engineering, and other than that we had done your reasoning In that we had done your verbal reasoning, and in that we had done your general mental ability and the logic reasoning. In non-verbal reasoning, we had done series analogy, classification, analytical reasoning, measurement, water image, method, figure, completions of incomplete pattern, figure matrix, paper folding, paper fitting, rule detection using of identical figures, cubes and dice, and DOS distribution as well. And now for the sake, we'll go ahead for the same. We had done we are dealing with quantitative aptitude. In quantitative aptitude, we had done operations on numbers, SCF and LCF numbers, decimal fractions, simplification, square roots and cubes, problems on numbers, problems on ages, certs and indices, percentage, profit and loss we are dealing with, and we are dealing with ER diagram, and we are dealing with that is being the English vocabulary. In terms of computer-based numerical and statistical technique, we had to cover up the computer arithmetic error. Here we have to cover up the floating point arithmetic machine abscon, round-off error, chopping error, truncation error, associative and distributive law of floating arithmetic, inherent error propagation, numerical instability, root of equation, second method, Newton-Raphson method, and a fixed point iteration method for a simple root, and the derivations of the rate of the conversions, static and accelerations of conversions, modified Newton-Raphson method for the multiple roots, White method for polynomial, Bystrom method for the quadratic factor, and computer algorithm of these methods. Unit 2, we have to cover up the interpolation, which has been the algorithm and the error analysis of the Lagrange and the Newton divided differences interpolation, relationship in the various differences operation, that the piecewise linear interpolation, the cubic spline interpolation, naturalist spline, the Chebyshev's polynomial approximation, Langkow's economization of the power series. In curve fitting, we have to cover up the linear and non-linear least square approximation, third conditioning in the least square methods, Gram-Schmidt's process of orthogonalization, computer algorithm of least squares, curve fitting. And in third, which has been the differentiation and integration, we have to cover up the method based on the interpolations and the finite differences, Richardson extrapolation and integration. We have to cover up the error analysis of trapezoidal and the Simpson method, Newton's that has been the Cotes integration method, Gaussian's integration method, Gauss-Legendre method, Roberto integration method, and the Radau integration method, error terms in the integration method as well. In Unit 4, we have to cover up the solutions of simultaneous linear algebraic equation, where we have to cover up the Gauss elimination method and the condition system, which is in the condition number, successive and relaxation method of the rate of the conversions. Solution of ordinary differential equation, we have to cover up the single step method, and we go to the second order, third order, and fourth order method. And whereas we have to cover up the multiple step method, predicative corrective method, statistical technique, statistical hypothesis, test of hypothesis, type 1, type 2 errors, and level of significance, and test involving the normal distributions as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share, and subscribe to our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.